Now we are in a good position to write down a general method for solving problems that involve forces in the motion. In other words, we want to solve for the kinetics of particles. But before we write down a method for the kinetics, let's try to recall what we wrote down as a method for solving kinematics of particles problem. So the method that we had for kinematics of particles was, we had 4 steps. So method, let me write that down again. Method for solving problems in kinematics of particles module. Okay, so our step 1 was choose a coordinate system. So we could choose Cartesian, tangent normal, polar coordinate system, sometimes maybe a combination of the 2 or 3. Step 2 was show the coordinate system as well as position variables. So for example, if you were solving the pulley problem where you had multiple blocks, you had multiple pulleys, you had to indicate the positions of every block, and sometimes if the pulleys were moving, even their positions, and then you try to use the geometric constraints of the problem to get a relationship. So showing the position variables was very important in those kinds of problems. The step 3 was write down velocity and acceleration expressions in the chosen coordinate system. And finally, you solve for unknowns. So you had to identify how many unknowns you had and how many equations you had. You had to make sure that the number of unknowns were same as number of equations, scalar equations, so that you could solve for them. And if you found that you had more unknowns than the equations that you could solve for, then you went back to the problem and made sure that you didn't miss any input information given to you in the problem. So this was the general method for solving problems in kinematics of particles. In this particular module, for solving the kinetics of particles problem, we will have a similar method, okay? And we will refer to these 4 steps as kinematic analysis. Kinematic analysis. So in future, if I say, please do kinematic analysis on the particle, these are the 4 steps that you will carry out, okay? Now, kinetics of particles involves actually doing kinematic analysis. So everything that you learned in the previous module would be applied in this module as well, because after all, in this particular module, you're applying sigma f equal to ma. On the right hand side, you have the acceleration. So unless you can solve for the acceleration to the largest possible extent, you won't be able to solve the problems. So let's write a general method. So step 1 is, again, same as what was the step in the kinematics of particles method. Choose a coordinate system and then step 2 would be perform as much kinematic analysis as you can. Okay, and remember, what is the goal? The goal of this step is to get the velocity and acceleration as much as you can. So the kinematic analysis that I'm referring to here in step 2 is basically this kinematic analysis in 4 steps that we talked about in previous module. All right, so you've already chosen the coordinate system. This is step 1, so this part is already done. You already showed the coordinate system and position variable, let's say, in step 1 of this method. Then that's done. You have to write down the velocity and acceleration, and you have to solve for velocity and acceleration as much as you can. And sometimes you will be able to solve for velocity and acceleration completely. Sometimes you won't be able to. Okay, so but you still have to do this analysis so that you can get to a point where maybe you can use some part of information from this step in the next few steps. Step 3 is to draw free body diagram of the particles. So you could choose one particle, you could choose multiple particles, and you could draw a free body diagram of the whole system. So whatever your object of attention is, you have to draw a free body diagram of that, right? So a couple of things to remember when you draw free body of the particles is, 1, is that you have to isolate the chosen particle, and I will write S in parentheses to indicate if you choose more than one, then you have to isolate them. Isolate the chosen particles from its surrounding. Second point to remember is to always show the coordinate system overlaid on the particle. So for example, if you were solving a problem where there was a block and this block was resting on an incline or moving on an incline, right? Then if you draw free body diagram, you would draw this object A all by itself without showing the incline. You will show the weight, MAG, you'll show the normal reaction, you'll show the friction force, right? And you will also show the coordinate system. So if you pick your coordinate system to be a line like this, X and Y shown like this, then you will also draw X and Y here. So notice this is a repetition. You'll draw your coordinate system here in the problem and you will repeat it here again. And if you had two particles, let's say A was joined with another particle B, right? Then you would also have a force of tension, right? And then for the B, when you draw its free body diagram, you'll show all those forces, right? And I'm not drawing them, but you will again add the coordinate system. So just keep that in mind, that you always have to show the coordinate system overlaid on the free body diagram of the particle. So after we draw the free body around the particle, step 4 is to apply Newton's second law, which is sigma F equal to ma. Right? Now you will write this law and you will resolve the force and the acceleration in your chosen coordinate system. So if you pick Cartesian coordinate system, then you will have forces and acceleration resolved around the Cartesian coordinate system. If you choose tangent normal, then you will write appropriate relationship for that. If you use polar coordinate system, then you will use relationship for polar coordinate system. Okay, and finally, you will solve for unknowns. Okay, so now you can see that if, let's say, you were solving a problem involving forces and the acceleration, then the kinematic analysis step, which is the step number 2, will give you acceleration possibly in 2 directions, right? It might give you acceleration along X and Y direction, it might give you acceleration along tangent and normal direction, or acceleration along r and theta direction, right? So you will essentially have 2 equations over there, okay? One for X and Y, or one for tangent normal, or one for r and theta, right? So you'll have 2 equations over there, and here also, if you were writing this equation in a plane, you will get 2 more equations, so you'll get 4 equations. So altogether, the kinetics of particles method that we have written down over here in 5 steps will give you 4 equations from which you can solve for 4 unknowns. So if you're lucky, you will get every single information about acceleration from step 2, which you'll be able to plug in 3 and 4 and solve for the forces. But there will be problems where accelerations would be unknown. Maybe there will be a part of the force that will be known to you, okay? And then you'll be able to solve for a combination of forces components and acceleration component. But in the end, as long as you have enough equations to solve for enough unknowns, then you are in good shape.